Welcome to the last section of this video. This is a section that was in the review part of the chapter, and I skipped over it at the beginning, and we need it now quite a bit. It's going to bring in factoring again, so if you have questions or struggles with factoring, you need to get that figured out, learn how to do that, reach out to me. There's also the Math Lab. There's also the CAE, the Center for Academic Excellence in the library. There's lots of ways to figure it out, but you do need to figure it out. All right, so let's take a look. Rational expressions. These are just quotients or a division of two polynomials. So you want to think fraction here. You could see a couple of examples here. These are rational expressions. They have an x in the denominator. You see that? And they're both fractions. Here we go, rational, rational, rational. With rational functions, just a reminder, I guess, that the domain is all possible x values. And with rational functions, we usually state this as the opposite or the negative of that. We look and say, hey, when is the denominator not equal to 0? We've already talked about this some. These problems, find the domain. We've got 2 over x minus 3, so x minus 3 can't be 0, which means x cannot be 3. X can be anything else, just cannot be 3. In number 2 here, we get the same thing, but it's not so obvious what the zeros of the denominator are. If you factor it, which I did here, and then look at the denominators, x can't be 5, because if it was, it'd be 5 minus 5 is 0. And 0 times, this ends up being 6, is 0. Doesn't matter what this is. 0 times anything is 0. So x can't be 5. If it is, you can even plug it in here and see the denominator is 0. Same way, negative 1. If we plug negative 1 in, we get negative 1 plus 1 is 0. 0 times this number is going to be 0. So the domain is anything except 5 and negative 1. All right, number 3, simplifying. Anytime you're working with rational expressions, you want to see, can we simplify it and make it easier on ourselves? To do that, we're going to factor where we can. In this case, we factored the numerator. To get 3x squared, I put 3x times x. To get negative 8, I need to do 8 and 1 or 4 and 2, and I want to get negative 10. So if I think about it, if I put 8 here, that's going to be way too big. Maybe 1 and 8, maybe that would work. But if we end up putting 4 here, that gives me 12 and 2. When I take negative 12, positive 2, that gives me that 10x I need. So I've got 3x squared here. I've got the 10x like I talked about. And then we've got negative 8. You also notice then these are the same. We can divide these out because x minus 4 divided by x minus 4 is just 1. And 1 times anything is what I started with. So to simplify this expression is equal to 3x plus 2 as long as x is not equal to 4. If x is equal to 4, this is undefined. All right, let's take a look here at this one. This is called Pumpkin Smash Bingo. It's a game we might play in class if we have time, but I've got a feeling we'll run short. Multiplying. We're going to actually start multiplying fractions. How do you multiply fractions? 2 ways. One is to multiply straight across numerators, denominators. 8 times 3 is 24, 9 times 2 is 18. And now we can divide numerator and denominator by 6 to get 4/3. Or we could simplify first. You see we've got 8 and 2. We can divide 2 out of both of them. Then we've got 3 and 9. We could divide 3 out of both of them. That leaves me with 4 and 1, 3 and 1. My final answer is 4/3. Either way, you see we divided by 6 here. Here we divided by 2 and 3. So that's dividing by 6. All right. We do the exact same thing with the algebraic equation. Sorry, I'm yawning. Here we go. We've got a fraction times another fraction. It doesn't matter what the denominators are. We can just multiply them together. We multiply across the numerator, denominator. But it might be easier to factor first. And so you can see here, there's a 9 that we can divide out of each of these terms. So I did that. And there's a 9 here. So I divided that out. You can now see we can take 9 divided by 9 as 1, n plus 6 divided by n plus 6 is 1. We're left with 2n squared over n plus 8. That's multiplying fractions. Dividing fractions is actually fairly similar. We just flip the second fraction from 3/2 to 2/3, and then we multiply. We've already talked about how to multiply. We just multiply straight across. We get 8 times 2 is 16, 9 times 3 is 27. Same way with fractions. We've got a fraction divided by another fraction. We're just going to flip the second fraction here, change it to multiplication, and then factor and simplify. So you can see here, the 3b's cancel or divide out. Here I'm going to factor the denominator. That becomes b plus 5, b plus 8. Factor the numerator. I can divide 6 out of each term. I get b plus 5. The 6 divided by 3 is 2. b plus 5 divided by b plus 5 cancels. We get 2 over b times b plus 8. All right, let's look at slide 8 here. It says, this is kind of a mess. Looks really complicated. But just take it one step at a time. You can see a fraction divided by another fraction. Fraction divided by another fraction. And then how do we divide fractions? We just multiply by the reciprocal. So you can see we took this second one and flipped it over. And now we've got this expression to simplify. We can factor the numerator. We get x minus 7, x plus 4. And then divide out and simplify. Multiply across, right? X minus 7 over x over 4x. I know this is a pretty quick review. Feel free to pause it and go back and look at it yourself. How do you add and subtract fractions? Well, here we've got common denominators. We can just keep the denominators the same and add the numerators. 2 plus 5 is 7. Same way here. If we've got two fractions with common denominators, we could just add them, keep the denominator the same. Here we got b minus 2, and here we have b plus 4. We then can just combine them, combine like terms. B plus b is 2b, negative 2 and 4 is positive 2. And then we can factor. I factored a 2 out of each term here. I factored a 6b out of each term here. And then simplify. 2 and 6 can be reduced to 1/3, so we got a 3 in the bottom. These can't cancel. I'm left with b plus 1 over 3b times 5b minus 1. All right, take a look at 14 here. What if the denominators aren't the same? Well, we need to make them the same, right? To get denominators the same, we have to multiply the numerator and the denominator by the same number. Here with 9 and 3, you can see 9 is the greatest common multiple. So I can multiply this by 3 and this by 3. So the 2/9 stays the same, but now I have 15 over 9. We now have common denominators, and then we add them and keep the same denominator. Same idea here. I need to subtract. Addition, subtraction are the same. Common denominators. Well, 5 and 6 and x, they don't really go into each other. There's no common factors. So I just have to multiply this by 6x and 6x, and this by 5 and 5 to get the same number in the denominator. This case gives me 30x in the denominators. This would be 12x squared minus 25. That gives me this expression. I'm tempted to factor out a 3 or something, but you'll notice this isn't divisible by 3. So there's nothing I can just factor out. So there's no further simplifying I need to do here. All right, a few rules for adding and subtracting rational expressions. We need common denominators first. We then add or subtract. Sometimes we might have to distribute a negative. The numerators, and we keep the denominator the same. And then we simplify. If we have time, this bingo board, you can fill in. These are the answers to a bunch of questions. You could fill them in a random order up here, and we could play bingo. But I have a suspicion we won't have time for that. All right. Thank you, guys. That is Chapter 2. Have a great day.